Now, welcome back. In the previous session, we have understood about the slabs and the different types of slab, their action, load transfer mechanism, and the reinforcement data that is to be provided for one-way slabs and two-way slabs. Now, we shall take up a detailing of one-way slab, and this is the given data. We need to we need to draw the sectional elevation and plan for the one-way slab showing all the reinforcement details. So the details are given here. Room dimensions 3 by 8. This is into in dimension. The overall thickness of the slab is 130 mm, or it is also called as overall depth of the slab 130 mm. Wall thickness 230 mm. Main bars are 10 mm diameter bars spaced at 160 mm center to center. Distribution bar or distribution steel 8 mm diameter bar spaced at 200 mm center to center. And one clause is given here. This is very important, so you need to note this. Bend 50% bars near the support. So this is applicable only for main bars, not for the distribution bars. Okay, so we shall now start with the section elevation and plan. Okay, so before that we shall note down the dimension. Okay, so this is into in dimension. This is length and width. So Lx is 3, Ly is 8. So Ly by Lx is greater than 2. Ly by Lx greater than 2. So it is a one-way slab. Okay, so this is what we have understood now. So I will first draw the sectional elevation, and below that is a plan. So this is how we follow the pattern. Bottom is for the plan, top one is for the elevation or sectional elevation. So first I will draw the plan so that you will understand how the plan is to be drawn and the corresponding cross sectional elevation has to be taken. So this is the plan, the dimension. So I will be taking into in dimension. So this is 3 meter and this is 8 meter. Okay, so I now come back to this sectional elevation. So this I am going to draw a section line somewhere here and name it as section AA. So this is the plan, and above this will be the section elevation or cross section. So I project these lines and I will get the details here. Okay. So this is into in dimension, means I have to take the projection outside. So I project this, and outside is how much? This is wall thickness 230 mm. So it will be like this. Okay, so this is my wall or the support. So into in dimension is given as 3 meter. So center to center distance will be 3.23 meter. So this is the cross section of the slab, that is one-way slab, drawn from projecting the lines of the plan. Okay. Now, as discussed in the previous session, main bars are to be provided along the shorter span. So here I am going to provide the main reinforcement. So it is given as 50% bars are bent near the support. One bar will start from this end. It will run straight and it will stop at a distance of L by 10 from the support, from the inner face of the support. So what is L here? 3.23 meter by 10. So if I convert it into mm, it will be 3230 divided by 10. So 323 mm. So it can be rounded up to 320. Okay, so this is 320 mm. So you will be stopping the bar here, then bend it up to 45 degree like this, and then continue again. Okay, so this is one bar. Behind it there will be one more bar running Okay, so it will be starting from this end, it will go like this, it will run in this direction, stop here at a distance of L by 10, this is X by 10, so it is same, that is 320, and then bend it up to 45 degree, continue it inside the support. So this is how the section elevation looks in the slab for main reinforcement. Now for the distribution steel, it will be like this. So distribution steel will be running perpendicular to this direction. So they are shown in a dotted fashion. And these are placed above the main steel in the bottom zone and below the main steel in the top. Why this bend up is provided? Because there is no shear reinforcement provided for the slabs. Because the thickness of the slab is small, the overall thickness is 130 mm. Since the thickness is small, it is difficult to provide the shear reinforcement. So instead of providing shear reinforcement, the alternate bars will be bent up at 45 degrees at a distance L by 10 from the support and taken inside the support at the top. Because the tension will be at the top near the support and at the bottom near the midspan. Okay, so this is how the reinforcement details look for one-way slab in the cross-sectional view. So the same thing if I look from the top, how does it look? I'll draw that now. So one bar will be running from this end. It will stop here. You need to stop the same thing. Okay, then continue it like this. Then the other one will start from this end. It will run up to this point. Same thing you need to project. Bend it at 45 degree. Take it inside. Okay, so this is my main reinforcement given as pi 10 at 160 center to center. Okay, same thing is to be noted here. This as well as this is pi 10 at 160 center to center. This will be the distribution steel. If there is no space, kindly adjust with this. So this is a distribution steel. I will mark it as distribution steel DS. Okay, this will be running in this direction. So these are distribution steels. Pi 8 at 200 center to center. So this is about the reinforcement details for the slabs. We call it as detailing of one-way slab. Okay. Now based on these detailings, we will find out the bar bending schedule that is going to give us the total quantity of steel required to provide the reinforcement for this slab. Okay. So that we shall take up in the next session. Thank you.